Good morning, children. So we are doing GP. So let us move on to the next question. Question number 8. Here the question says, find the sum of each of the following series. Okay. So the first one is 1 plus 3 plus 9 plus 27 plus da da dash plus so on till 10 terms. Okay. So here n is given to us, that is 10. The first term I know, that is 1, and the common ratio you can find 3 upon 1, 9 upon 3, 27 upon 9. Taking any pair you can find. Okay, so here r is 3, which is greater than 1. Okay, so we have to use this formula, Sn equal to a1 rn minus 1 upon r minus 1. Okay, so we know r, we know a1, yes, we know n because here is saying up to 10 terms. So substitute the values, you will get the answer. Okay, next is 1 plus half plus 1, 1 plus half plus 1 by 4 plus 1 by 8 da, 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 till the 11 terms. Okay, so here I know the first term, that is 1. Here ratio you can find half divided by 1. Okay, or you can do 1 by 4 divided by 1 by 2. So you get ratio half, that is less than 1. Okay, so we'll use this formula, Sn equal to a1 1 minus r to the power n upon 1 minus r. Okay, so n is 11 over here, a1 is 1, r you know it's half. Put the values, get the answer. Okay, question number 9. 1. Insert 3 geometric means between 3 and 48. Okay, so two numbers are given to us, 3 and 48, and in between these two we have to put insert geometric means. So let the geometric means be denoted as capital G1, G2, G3 be the required means. Okay, so in that way, after we have inserted these 3 geometric means, then we'll get the sequence this way. Yes, 3 comma G1 comma G2 comma G3 comma 48. Okay, so what you will observe that this is the first term, 3 is the first term, and this is your fifth term. Okay, 48 is the fifth term. So now you can find the common ratio. Okay, so let r be the common ratio, then a5 is 48, and a5 means what? a1 into r to the power 4. a1 you know it's 3, so just put 3, then simplify and you get r equal to r to the power 4 is equal to 2 to the power 4. Powers are same, bases will be same, so r equal to 2. So now you know the common ratio. So once you know the common ratio and you know the first term, you know the common ratio and you know the first term, so in that case you can write the G1, you can write G2, you can write G3. Okay, so your G1 will be the second term, that means a1 into r to the power 1. Put the values, you'll get equal to 6. Okay, same way you will get G3, G2. Okay, question number 10.1. Find the 3 numbers in GP whose sum is 14 and product is 64. So find 3 numbers in GP whose, so let us consider the 3 numbers in GP be this: a upon r, comma a, comma ar. According to question, their sum should be 14, okay, and product should be 64. So sum means a upon r plus ar is equal to 14. Yes, simplify this. Okay, and next is saying that product should be 64. So a upon r into ar cancel, a cube equal to 64, so a equal to 4. Now this a equal to 4 can be used in equation 1, okay, and that's how you can get value of r. So once you put a equal to 4 in equation 1, then you get this. Okay, simplify, at the end you are getting a quadratic equation. Okay, and then simplify further, you'll get 2 values of r equal to half and r equal to 2. So once when you are taking r equal to 2, in that case a upon r will be 2, a will be 4, ar will be 8. Once you are taking r equal to half, in that case the numbers will be in this sequence. Okay, in this order, 8, 4 and 2. Okay, so the numbers are 2, 4, 8. Okay, these are in GP and these numbers satisfy the condition also. Sum is 14 and product is 64. Now question number 11.2. The sum of first 3 terms of a GP is to the sum of the first 6 terms as is 125 is to 152. Find the common ratio of this. So here the ratio is given. Okay, the sum of the first 3 terms of a GP is to the sum of the first 6 terms is this. Find the common ratio. Okay, so that means here is saying S3 is to S6 is 125 is to 152. According to question, 1 plus A1 plus A2 plus A3 upon A1 plus A2 plus A3 dash plus A6 is 125 upon 152. But right now here in this question, we don't know whether R is greater than 1 or less than 1. So let us assume that R is less than 1. Okay, let us assume that R is less than 1. So S3 upon S6 equal to this. Since we have assumed R to be less than 1, so I can write S3 by this formula, A1 into 1 minus R cube upon 1 minus R and whole divided by A1 into 1 minus R to the power 6 upon 1 minus R. Okay, this 1 minus R and here 1 minus R, these two will get cancelled. A1 will get cancelled. Okay, and we are left with 1 minus R cube upon 1 minus R to the power 6 equal to 125 upon 152. Cross multiply. Okay, and we get this. Okay, now you can see we are getting, so what we can do is here 152 R cube minus 125 into R cube whole square equal to 27. Okay, so in place of R cube, okay, in place of R cube I can put X. Yes, so I'll get 125 x square minus 152x plus 27. So I'm getting a quadratic equation. Solve this quadratic equation, okay, and you'll get x equal to 1 and x equal to 27 upon 125. But x is nothing but R cube. So here R cube equal to 1, that means R is 1, and in this case R equal to 3 by 5. Okay, so here R equal to 1 not possible, as R must be greater or less than 1. Okay, you know that for this formula, okay, either R is less than 1 or greater than 1. It cannot be 1. Okay, because if it becomes 1, then denominator will become 0. Yes, so that is not defined. So here we are getting R equal to 1 and R equal to 3 by 5. So R equal to 1 is rejected. Okay, because R is either less than 1 or greater than 1. So here R equal to 3 by 5. And in question we were supposed to find the common ratio only. So we got the common ratio. Okay, R equal to 3 by 5. Now question number 11.3. In a GP, the third term exceeds the second by 6. Okay, so third term exceeds the second by 6. So suppose second is 3, then the third term will be 9. Okay, and the second term exceeds the first by 9. Find number 1 the first term, number 2 the common ratio, number 3 the sum of the first 10 terms. Okay, so according to question, A3 means third term exceeds the second by 6. That means the third term is equal to A2 plus 6. Okay, that means A3 minus A2 will be equal to 6. Okay, and A3 is what? A1 R square. Yes, minus A2 is what? A1 R. Clear? Now in these two, what is common? A1 R is common. So A1 R in bracket R1 R minus 1 is equal to 6. Put this equation 1. Next is saying that in this question is saying, and the second exceeds the first by 9. Okay, the second exceeds the first by 9. Okay, so here A2 is equal to A1 plus 9. So A2 minus A1 is equal to 9. A2 means A1 into R, and A1 is simply A1 is equal to 9. Now A1 is common over here, so I get A1 into R minus 1 equal to 9. Okay, now equation 1 and equation 2, if you observe, if I divide equation 1 by this 2, then R1 R minus 1 cancelled, A1 cancelled, we are left with R. Okay, so equation 1 divided by equation 2 gives R equal to 6 by 9, that means 2 by 3, which is less than 1. Okay, so I got R. Okay, now use this R in 1 or 2 to get value of a1. Okay, so we have put this r in equation 2 and I get the value of a1, that is minus 27. Clear? Now I can find sum of first 10 terms. Okay, because I know a1, I know r is less than 1, so I have to use this formula. Okay, so substitute the values and you'll get the answer. Okay, next is question number 14, sum to n terms. Okay, equation it is 1 plus 11 plus 111 plus da da dash. Right now if you see, this is neither in AP nor in GP. Okay, but we can convert, okay, we can convert this into GP. Okay, how we can do it, let's see. So what we'll do is we will multiply throughout by 9. We'll multiply throughout by 9 and we'll divide by 9. So doing so, we'll get 9 plus 99 plus this 999 plus so on till n terms and whole divided by 9. Okay. Now in next step, what I can do is this 9 can be written as 10 minus 1. This 99 can be written as 100 minus 1. This 999 can be written 1000 minus 1 plus da 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 so on. Yes. So in this bracket altogether we have n terms. So here we have n groups. Yes, we have got n such groups and 1 upon 9 here. Now open the bracket. Okay, open the bracket. Write all the terms multiple of 10 together. Okay, and this minus 1 all one side. So we are opening each group and from there 10 plus 100 plus 1000 n terms, because n groups are there, so you will get n such numbers multiples of 10. Yes, and then plus, okay, plus and minus 1 minus 1 minus 1, so n such groups were there, so you'll get n times this minus 1 minus 1 minus 1 so on. Yes, now if you observe this bracket, okay, now you can see that these terms are in GP. 100 divided by 10 is 10, 1000 divided by 100 is 10 and so on. So this is in GP. So first term is 10. Okay, here common ratio is 10, that is greater than 1, so we have to use this formula. Okay, and here you can see that n times minus 1 is appearing. Okay, so that means minus n. Yes, so simplify this and you get the answer. Clear? Here question 2 is homework for you. Same way, if you observe, this is neither in AP nor in GP, but we can do some manipulation and we can make find the sum. Yes, so from here you can see 6 can be taken out as common. So once you take out 6 as common, so you are left with 1 plus 11 plus da da da. Now for these terms in the bracket, okay, for these terms in bracket you have to follow the same procedure. Okay, because 1 plus 11 plus 11 1 how did we do the manipulation? Same manipulation you have to do for here, and that way you can get the answer. Okay, question number 15, find the sum to n terms of this. Okay, in this case also, if you see, this is neither in GP nor in AP, but here for each term 4 is common, so 4 comes out. Then we are left with 0.1 plus 0.111 plus 0.111 to n terms. Okay, still whatever we got in this bracket cannot be cannot be found using AP or GP. Now what we'll do is we will do some manipulation. So we will multiply throughout with n and we'll divide by we will multiply throughout by 9 and we'll divide by 9. Okay, so we get 0.9 plus 0.999 plus 0.9999 to n terms. Clear? Now this 0.9 can be written as 1 minus 0.1. This 0.99 can be written 1 minus 0.01. This can be written 1 minus 0.001 and so on. So that's how we get n groups. Okay, in next step what we will do is we will write these ones together. Okay, so we'll get n times 1. Okay, and we'll write this 0.1 0.01 0.001, okay, in separate bracket. Okay, n times, so we get this. So here 1 plus 1 are n times, so simply when you add them you get n. Yes, and here minus sign will come out. Okay, for from each term minus sign will come out. We are left with 0.1 plus 0.01 plus 0.001 plus n terms. Okay, so here if you observe now, these are in GP. Okay, so 0.01 divided by this 0.1. Okay, you will get zero point 0.1. Okay, when this 0.001 will divide by this 0. This, so you will get 0.1. So you can see that common ratio over here is 0.1. First term is 0.1 and common ratio is less than 1. So we'll use the formula, okay, for the GP, and we can write the sum of these terms, okay, like this term. Simplify this and that's how you'll get the answer for this, okay, for this series. Question number 19, sum two n terms of the following series. Okay, here's series is given like this: 1 plus 4 plus 13 plus 40. Okay, so right now if you see, 4 minus 1 you are getting 3, 13 minus 4 you'll get 9. So you can see that this is not in AP. Okay, check whether this is in GP or not. 4 divided by 1 is 4, 13 divided by 4 is not 4, so this is not in GP also. Okay, but we have to find the sum of this. Okay, so first what we have to do is we have to find, okay, we have to find by what rule the nth term is written for this series. Okay, so we have to find the rule for which by which each term of this series is written. Okay, so how we can do that? Okay, so we have 1 plus 4 plus 13 plus 40 plus dash 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 n terms. Okay, so when we'll add n terms of this series, okay, when we'll add n terms of this series, how do we denote that sum? Sn. Yes, that sum is denoted by Sn. So we can write Sn equal to 1 plus 4 plus 13 plus 40 plus dash 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 plus an. Right now I don't know an is equal to what. Okay, but obviously there will be nth term. Okay, so let that nth term be an. So Sn equal to 1 plus 4 plus 13 plus 40 plus dash dash plus an. Next I will write the same series, okay, but I will leave the first step, first space, okay, blank. Okay, so the same thing can be written as Sn equal to, the first space will be left like this. So I'll start writing from the second position. Okay, so 1 plus 4 plus 13 plus 40 plus dash 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 plus an minus 1 plus an. Okay, now what we'll do is we will subtract this, the second one, from the first. Okay, so here we can see on the left hand side we have got Sn, here also Sn, so Sn minus Sn will be 0. Okay, then n, here we have 1, here we don't have anything, so simply copy 1 over here. Okay, then 4 minus 1 will be 3. Okay, then 13 minus 4 will be 9, 40 minus 13 will be 27, then so on, and then this an minus n minus 1 will be this. So you can see that from here till here how many terms are there? N minus 1 terms are there. From here till here n minus 1 terms are. That means whatever I've written in bracket, there are n minus 1 terms. Okay, and last this an term is written with minus sign, minus an. Clear? So here I have in bracket I have got n minus 1 terms, so you should remember this. Okay, now in next step this minus an will come on the left, so I get an equal to 1 plus 3 plus 9 plus 27 plus dash plus 2 n minus 1 terms. Why? Because in this bracket we have got n minus 1 terms, that's why 3 plus 9 plus 27, okay, 2 n minus 1 terms. Okay, here if you observe this series in this bracket, okay, each term, okay, this terms are in GP. Okay, because 9 divided by 3 is 3, 27 divided by 9 is 3. Okay, so in order to find the sum of these, okay, it is easy for us. Yes, so using the formula of GP, we can find the sum of this n minus 1 terms in this bracket. So here r is 3, that is greater than 1. Okay, so that means an is equal to 1 plus, and this can be written using the formula, the first term into r to the power, how much ever terms are there. So how many terms are there? N minus 1 terms are there. So 3 to the power n minus 1 minus 1 upon 3 minus 1. Okay, so I get 1 plus 3 by 2 in bracket 3 to the power n minus 1, okay, minus 1. Clear? Now open the bracket. Okay, so when you open the bracket, you will get 1 minus 3 by 2 plus 3 into 3 to the power n minus 1 upon 2. So I get minus half plus this 3 to the power 1. Okay, bases are same, power will be added, so I get 3 to the power n upon 2. Okay, 2 is common in denominator, so that 2 comes out, so half comes out, so we are left with 3 to the n minus 1. So for this series, the series that we are supposed to find the sum of this series, nth term of this series is given by this formula. Okay, so if you want to check, you can check. Suppose I want the first term, so in place of n I have to write 1, so half 3 to the power 1 minus 1, so it will come 3 minus 1 2. Okay, 2 divided by 2 is 1, so you can check the first term is 1. Next term is 4, so you can check. If I put n equal to 2 over here, so it will become 9 minus 1. Yes, that means 8 that means 8 divided by 2, 4, so you can get the second. So we got the rule, okay, by which each term of the series is defined. Okay, now we can easily find the sum of the series. So Sn equal to summation of an, okay, the nth term, where n starts from 1 and it goes till n. Okay, now open the bracket, or here this is constant, so it will come out. Then you can simply write this summation as this. Okay, so you get this. Okay, and for this, you know, it's n. Now next, this 3 to the power n, okay, this 3 to the power n means what? It means 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus that is 3 to the power n. Now you observe that this is nothing but GP. Yes, common ratio is 3 over here. First term is 3. So use the formula of the GP, okay, for the sum, and there you can get the sum. Okay, simplify it and you'll get the answer. Okay, so this is all for today.